Today we're going to learn about the first steps of factoring, and before you do anything as we progress along in this unit, you always need to ask yourself, is there GCF, which stands for the greatest common factor? And the greatest common factor is the largest number or the greatest number that each of the numbers is divisible by. So if we look at number 1, we need to figure out the biggest factor that 10 and 30 share in common. Now, some of you are going to be able to do this quickly. Some of us are going to need to write out the factors, and that's quite all right. So the factors of 10 are the following, and then the factors of 30. Okay, and then we look to see which one is the greatest common factor. And as you can see, the 10 is the largest factor that these two numbers share in common. So then the GCF would equal 10. Okay. One helpful hint that might shorten up problems for you is see if one of the numbers is divisible by the other one. So like if I take 72 and divide it by 24, do I get an even number? And in this case I do, which means then the GCF has to be 24. Because the largest factor of 24 is 24 itself, and if it goes into 72, then that's the largest GCF. And then same thing with number 3. Notice that 15 is the smallest number, but it goes into both 90 and 60, so our GCF is 15. Okay. All right, now let's talk about finding the greatest common factor of a variable. So kind of the same concept that we just did when we tried to take 90 and 60 and divide it by 15. We do the same thing with the variables. So we need x squared to go into x to the 7th, which is fine. So then the GCF is x to the 2nd. Okay, so basically you look for the largest exponent that can go into everything. So 7 can't go into 2, so that's why it's not x to the 7th. So then if I look at example 2, you need to take the GCF of the x's and the y's. So we have x to the 5th and x to the 1st. Okay, 5 doesn't go into 1, but 1 goes into 5. So my GCF is x to the 1st. And then same thing with the y's. If I wrote this out, how many do they share in common? They share y to the 2nd in common. Okay. Which you can see then y 2 can go into 3 addition-wise, but 3 cannot go into 2. Okay, and then the last one, so we look at a. We have a to the 3rd, b. We need to take it into consideration even though it's not in this multiple. And then c to the 3rd. All right, I'm going to do one with you guys and then pause the video, try the other 3, and then check your answers. All right, so the GCF of the coefficient, remember that coefficients are the numbers in front. So between 4 and 20, the greatest common factor would be 4. And then between x to the 2nd and x, the greatest common factor would be x. So my final answer is 4x. Okay, go ahead and pause the video. Okay, here's what you should have gotten for your 3 answers. Let's go over the first 2. Something that you might have not had was the negative. So we're going to take a little active note here. So you always need to take out the negative if the leading coefficient is negative. I'm going to use LC for leading coefficient. Okay, so notice that This is negative right here, and this is negative right here. So you have to take the negative out. Okay, then find the GCF of the coefficients, the GCF of the variable, and then put the two together. Okay. All right, let's go ahead and then take a look at the last one. This one was a little bit different. So first, take the GCF of the coefficients, which would be 2, the greatest common factor that goes into both 4 and 6. And then take the GCF of the variable. So that entire x minus 1 is the factor that they share in common, so you take that out. Okay. All right. So remember with the distributive property, we distribute to everything inside the parentheses. So this is 12x to the second. Remember that when you multiply powers same base, you add the exponents, plus 18x. Okay, and if I looked at the next one, distribute, that's 70x to the second, plus 14x to the third, minus 7x to the fourth. Okay, so once again, when you multiply powers of the same base, you add the exponents. So basically, factoring out a GCF is just the reverse of the distributive property. So you're going to find this 3x that they shared in common, if you're looking at number 1. Okay, notice that both these terms have 3x, and we're going to go the other direction. We're going to take it out. So for example, if you have 16 and you take out a factor of 2, what is left over? Well, 16 divided by 2, you would get 8. If you take out a 3x of the next example, essentially what you're doing is just dividing, and you get 3x. And then lastly, if you take out an x out of this one, you're left with 2 plus 5, which would just be 7. Okay. All right, so when you factor out a GCF, make sure that you take out a number, a variable, a negative sign. This is one we already took an active note about, so make sure that we really pay attention to this one. Combination of the above, and then if the expression cannot be factored, it is considered prime. So that means if you can't take a GCF out, you can't do anything else, which we're going to learn over the next couple days, then the problem is considered prime. Okay, so step number 1, identify the greatest common factor. Well, the greatest common factor of the coefficients would be 7. The variables does not have a greatest common factor. So I take out a 7 out of each term. Make sure you put the GCF on the outside, so you get 2x plus 3. So what we did was we found the GCF, took 14 divided by 7, 21 divided by 7. Make sure that you include the GCF on the outside. Okay. Example number 2, the GCF of the coefficients is going to be negative 4. Okay, so you had to take a negative out because the leading coefficient is negative, and then x. So divide everything by negative 4x. Make sure you put that on the outside, and you get 3x plus 4 on the inside. Okay. And then lastly, GCF in this example would be 2xy. So divide everything. And if it's hard for you to see it written like that, then divide each one by 2xy. Just make sure you put 2xy on the outside, and you're left with 2x plus 5y. Okay. All right. Let's go ahead and go to the next page. Okay. Now, you guys can always check your work too to make sure that you are doing it correctly. Remember that factoring is the undoing of the distributive property, so you can check your work by going through and doing the distributive property. So for example, our GCF in this would be 3. So we divide everything by 3, and I'm left with 4a plus 1. Remember, that does not go away. Sometimes you guys think that 3 divided by 3 is 0. It is not 0. It does not go away. And then to check your work, distribute that back through to make sure you did it correctly, which we did. Okay. And then this is your answer, though. The factored form is your answer. Okay. All right, let's take a look at number 2. So the GCF in this example of the numbers, the greatest common factor that can go on to all of that is 2. And then the greatest common factor is x squared. So we take an x squared out of everything, a 2x squared, sorry, and we're left with 7x to the third. Remember that when you divide powers the same base, you subtract the exponents, plus 5 minus 10x. Now we should write this in standard form, so that's the highest exponent on the inside of the parentheses, and then working our way down. And then we can check our work by distributing that back through. So 14x to the 5th minus 20x to the 3rd plus 10x squared. I did my work correctly. Okay. All right, let's do one more. So if we take a look at number 3, the GCF of the coefficients, there isn't one, but of the variables, it's x plus 4. So you take the GCF out of each term, and you're left with 5 minus 2x. Okay. You need to be careful in this problem, though. Notice that this parenthesis is not in standard form, so we have a little bit more work to do. So we have x plus 4, and then negative 2x plus 5. Let's put it in standard form. And then these leading coefficients, so once it's in standard form, these first terms cannot be negative. So you take it out and you just throw it in front. Just make sure you take the negative out of everything. So take the negative out of everything. Okay, so go ahead and try number 1 and 2 below. 3 and 4 we already did, so you don't need to go through them. So go ahead and try them and hit pause. Okay, here's what we should have gotten for our final answers for those 2 problems. Remember to take the GCF out and then just divide each term by that. All right, let's go ahead and go to the next page. This is the last page of the notes. So for number 1, the GCF of the coefficients is going to be 3. And then the variables, so x to the second is the largest one that can go into everything. And then y to the second is the largest that can go into the y's. So if you need to, write each one of these separately, or you can just write it all together like that. And then we have 2x minus 3y plus x squared. Okay, and what do we have to make sure that we do in the front? Write the GCF. Sorry, I kind of ran out of room on that one. Okay. Okay, let's look at number 6. So notice that it's already in standard form for us, the highest exponent coming first. And then you have a negative here. So we have to take that out. The leading coefficient cannot be negative. So I can take a negative x out, and I'm left with x to the 4th minus 6x squared plus 3. Make sure that you divide, you switch all of the signs when you divide by a negative. Okay. All right, let's go ahead and do number 7 together. Actually, we already did 7, so we're going to skip that. Let's take a look at 8. So number 8, there isn't any GCF between x to the second and 3, but notice that they both share 9 minus x in common. So that's going to be our GCF. And we're left with x squared plus 3. Okay, because when you divide this by 9 minus x, this cancels. Divide this by 9 minus x, this cancels. So then you're left over with x squared plus 3. Okay, but we're not done with this problem. This is one of the ones you have to be careful about. Looking inside the parentheses, everything is not in standard form. So we need to switch around this first parenthesis, and then hopefully you notice that there's a negative out in front, or needs to be a negative out in front, because the leading coefficient with inside the parentheses cannot be negative as well. Okay. All right, let's take a look at number 9. So there's 2 ways you could approach this problem. If you take out the GCF in the beginning, it might be a little bit complicated to figure out. So I would just take out the 2x minus 1 first, and then look with inside each set of parentheses to see if there's anything else you can do, which you can. So throw that 3 out in front, and you're left with x minus 2. Okay, so you got to be careful that you look inside each set of parentheses and make sure that the first term, once in standard form, isn't negative, and that there is not a GCF within it. And then lastly, if you take a look at this problem, there is not a GCF that you can take out, so it would be prime. Now that's not going to always be the case. Starting tomorrow, we might not be able to take a GCF out and it isn't prime. But for today, if you can't take a GCF out, it is prime. All right, thank you.